Good morning, dear students of IT 6256, IT Application Tools in Business. I am your OLC, Ms. Karen V. De Lara from AMA East Rizal Campus. So welcome to our virtual class today. We will be discussing the following: introduction to data communication, components of data communication, different data flow directions, types of signals to transfer data, types of transmission media, devices used in networking, network topologies, and kind of networks. So what is data communication? So it is the process of using computing and communication technologies to transfer data from one place to another or between participating parties. It enables the movement of electronic or digital data between two or more network nodes regardless of geographical location, technological medium, or data contents. It incorporates several techniques and technologies to enable any form of electronic communication. It's a very broad way to refer to all of this network technology on any platform or in any digital environment. For data communications to occur, the communicating devices must be part of a communication system made of a combination of hardware and software. Some common types of data communication technologies include telecommunications, computer networking, and radio satellite communication. Data communication usually requires the existence of a transportation or communication media between the nodes wanting to communicate with each other, such as copper wire, fiber optic cables, or wireless signals. For example, a computer is connected to the internet via a Wi-Fi connection, which uses a wireless medium to send and receive data from one or more remote servers. What are the different components of data communications? So, communication means this exchange of information or messages. When we talk with each other, we are exchanging information. For data communication, computers, telephones, and wireless devices that are linked in a network are used. Physical transfer of data over a point-to-point or communication connection between two nodes or endpoints, or point to multi-point, which is communication is accompanied via distinct type of one-to-many connection. So these are the different components of data communication. So we have message, sender, receiver, transmission medium, and protocol. So what is a message? It is the information to be communicated. Popular forms of information includes text, pictures, audio, or video. While sender is the device which sends the data messages. It can be a computer, a workstation, or a telephone handset. Receiver, it is a device which receives the data messages. It can be a computer, a workstation, or telephone handset. The transmission medium is the physical path by which a message travels from sender to receiver. Some examples include twister pair wire, coaxial cable, or radio waves. Protocol is a set of rules that governs the data communications. It represents an agreement between the communicating devices. Without a protocol, two devices may be connected but not communicating. There are three modes of transmission. Namely, we have simplex, half duplex, and full duplex. So the transmission mode defines the direction of signal flow between two connected devices. So we will first discuss what is a simplex. So in simplex mode, the communication is unidirectional. As on a one-way street, only one of the two devices on a link can transmit. The other can only receive, which can be represented in the following figure. So this is the figure. So we have the mainframe, direction of data going to the monitor. So keyboards and traditional monitors are examples of simplex devices. So the keyboard can only introduce input. The monitor can only accept output. The simplex mode can use the entire capacity of the channel to send data in one direction. Next, we have half duplex. So in half duplex mode, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive and vice versa. So the half duplex mode is like a one-lane road with traffic allowed in both directions. When cars are traveling in one direction, cars going the other way must wait. In a half duplex transmission, the entire capacity of a channel is taken over by whichever of the two devices is transmitting at the time. Walkie-talkies and citizen band radios are both half duplex system. So we have here a workstation going to another workstation and a workstation going to the other. So the half duplex mode is used in cases when there is no need for communication in both directions at the same time. And the entire capacity of the channel can be utilized for each direction. So the direction of data at one time going to another workstation and the direction of data at time two. So the next data flow direction is the full duplex. Full duplex mode, also called duplex, both stations can transmit and receive simultaneously. The full duplex mode is like a two-way street with traffic flowing in both directions at the same time. In a full duplex mode, signals going in one direction share the capacity of the link with the signals going in the other direction. The sharing can occur in two ways. Either the link must contain two physically separate transmission paths, one for sending and the other for receiving. Or the capacity of the channel is divided between the signals traveling in both directions. So we have a workstation here, direction of the data all the time going to another workstation. So one common example of full duplex communication is the telephone network. When two people are communicating by a telephone line, both can talk and listen at the same time. The full duplex mode is used when communication in both directions is required all the time. The capacity of the channel, however, must be divided between the two directions. So, what are the primary differences between the three modes of transmission? So, the simplex mode of transmission is where the communication is unidirectional or one way. Whereas in the half duplex mode of transmission, the communication is two directional, but the channel is interchangeably used by both of the connected devices. On the other hand, in the full duplex mode of transmission, the communication is bidirectional or two-way, and the channel is used by both of the connected devices simultaneously. So there are two types of signal to transfer data. So we have the analog signal and the digital signal. Analog signal are continuous and passes through or includes an infinite number of continuous values along its path. The curve representing the analog signal passes through an infinite number of points. So the analog signal also is a continuous electrical signal in the form of a wave. Next, the digital signal can have only a limited number of defined values. Although each value can be any number, it is as simple as 1 and 0. So the digital signal sends data as distinct pulses, either on or off, which is 1 and 0, in much the same way that data travels through the computer. So we have here various types of transmission media. So in data communication terminology, A transmission medium is a physical path between the transmitter and the receiver. It is the channel through which data is sent from one place to another. Transmission media is broadly classified in the following types. So we have the guided media and unguided media. So the guided media consists of twisted pair cable, coaxial cable, and optical fiber cable. While the unguided media consists of radio waves, microwaves, and infrared. So let's define the different types of transmission media. So the first one is the guided media. It is also referred to as wired or bounded transmission media. Signals being transmitted are directed and confined in a narrow pathway by using physical links. So various features of the guided media are the following. So high speed, secure, and used for comparatively shorter distances. So guided media are the physical links through which signal are confined to narrow path. Bounded media are made up of an external conductor bounded by a jacket material. So bounded media are great for labs because they offer high speed, good security, and low cost. So there are three major types of guided media. The first one is the twisted pair cable. So it consists of two separately insulated conductor wires wound about each other. Generally, several such pairs are bundled together in a protected sheath. So they are the most widely used transmission media. And twisted pair is of two types. So we have the unshielded twisted pair, or also known as UTP. This type of cable has the ability to block interference and does not depend on a physical shield for this purpose. It is used for telephonic applications. The second type of twisted pair is shielded twisted pair. But let us first discuss the advantages of unshielded twisted pair. So advantages are less expensive, easy to install, high speed capacity, susceptible to external interference, lower capacity and performance in comparison to a shielded twisted pair or STP, and short distance transmission due to attenuation. So the second type is the shielded twisted pair or STP. This type of cable consists of a special jacket to block external interference. It is used in fast data rate, Ethernet, in voice and data channels of telephone lines. So advantages of STP are, so we have better for performance at a higher data rate in comparison with UTP, eliminates crosstalk, comparatively faster, comparatively difficult to install and manufacture, more expensive, and bulky. So the second one is we have the coaxial cable. So it has an outer plastic covering containing two parallel conductors, each having a separate insulated protection cover. So coaxial cable transmits information in two modes. So we have the baseband mode, dedicated cable bandwidth, and broadband mode. Cable bandwidth is split into separate ranges. So cable TVs and analog television networks widely use coaxial cables. So advantages are the following. So high bandwidth, better noise immunity, easy to install and expand, and inexpensive. While its disadvantage or drawback, single cable failure can disrupt the entire network. So the third one is optical fiber cable. So it uses the concept of reflection of light through a core made up of glass or plastic. So the core is surrounded by a less dense glass or plastic covering called the cladding. So it is used for transmission of large volumes of data. So the cable can be unidirectional or bidirectional. The wavelength division multiplexer supports two modes, namely the unidirectional and bidirectional mode. So its advantages are the following: increased capacity and bandwidth, lightweight, less signal attenuation, immunity to electromagnetic interference, resistance to corrosive materials. So these are the advantages: difficult to install and maintain, high cost, and fragile. So the second type of transmission media is the unguided media. It is also referred to as wireless or unbounded transmission media. No physical medium is required for the transmission of electromagnetic signals. So unguided media or wireless media doesn't use any physical connectors between the two devices communicating. Usually, the transmission is sent through the atmosphere, but sometimes it can be just across the rule. Wireless media is used when a physical obstruction or distance blocks are used with normal cable media. So the following are the features. Signal is broadcasted through air, less secure, and used for larger distances. So there are three major types of unguided media. So the first one is the radio waves. So these are easy to generate and can penetrate through buildings. The sending and receiving antennas need not be aligned. Frequency range is 3 kilohertz to 1 gigahertz. AM and FM radios and cordless phones use radio waves for transmission. And it is categorized as terrestrial and satellite. The second one is the microwaves. It is a line of sight transmission. Example, the sending and receiving antennas need to be properly aligned with each other. The distance covered by the signal is directly proportional to the height of the antenna. The frequency range is 1 to 300 gigahertz. So these are majorly used for mobile phone communication and television distribution. The third one is infrared. So infrared waves are used for very short distance communication. They cannot penetrate through obstacles. So this prevents interference between systems. So the frequency range is from 300 gigahertz to 400 terahertz. So it is used in TV remotes, wireless mouse, keyboard, printer, and the like. So let's proceed now with some network devices. So hardware devices that are used to connect computers, printers, fax machines, and other electronic devices to a network are called
Wala ako.
network
Wala
devices.
ako. No. Nasaan ko?
So our hardware devices that are used to connect computers, printers, fax machine, and other electronic devices to a network are called network devices. So these devices transfer data in a fast, secure, and correct way over same or different networks. So the first network device is the repeater. So it operates at the physical layer. Its job is to regenerate the signal over the same network before the signal becomes too weak or corrupted, so as to extend the length to which the signal can be transmitted over the same network. An important point to be noted about repeaters is that they do not amplify the signal. When the signal becomes weak, they copy the signal bit by bit and regenerate it as the original strength. It is a two-port device. Next, we have the hub. It is basically a multi-port repeater. A hub connects multiple wires coming from different branches. For example, the connector in star topology, which connects different stations. Hubs cannot filter data, so data packets are sent to all connected devices. In other words, collision domain of all hosts connected through hub remains one. Also, they do not have intelligence to find out best path for data packets, which leads to inefficiencies and wastage. So next, we have the bridge. It operates at data link layer. A bridge is a repeater with add on the functionality of filtering content by reading the MAC addresses of source and destination. It is also used for interconnecting two LANs or local area networks working on the same protocol. It has a single input and single output port, thus making it a two-port device. Next, we have the switch. It is a multi-port bridge with a buffer and a design that can boost its efficiency. A large number of ports imply less traffic and performance. So a switch is a data link layer device, and it can perform error checking before forwarding data. That makes it very efficient as it does not forward packets that have errors and forward good packets selectively to correct port only. So in other words, switch divides collision domain of hosts, but broadcast domain remains same. Next, we have another device, which is the routers. So it is a device like a switch that routes data packets based on their IP addresses. So router is mainly a network layer device. Routers normally connect LANs and WANs together and have a dynamically updating routing table based on which they make decisions on routing the data packets. So router divide broadcast domains of hosts connected through it. Now let's proceed with computer network topology. So geometric representation of how the computers are connected to each other is known as topology. And they are divided into five different types. So we have the mesh topology, the star topology, bus topology, ring topology, and hybrid topology. So the mesh topology is each device is connected to every other device on the network through a dedicated point-to-point link. When we say dedicated, it means that the link only carries data for the two connected devices only. Let's say we have n devices in the network, then each device must be connected with n minus 1 devices of the network. So the advantages of mesh topology are no data traffic issues as there is a dedicated link between two devices, which means the link is only available for those two devices. Mesh topology is reliable and robust as failure of one link doesn't affect other links and the communication between other devices on the network. Mesh topology is secure because there is a point-to-point link, thus unauthorized access is not possible. Fault detection is easy. So while the disadvantages are the following. Amount of wires required to connect each system is tedious and headache. Since each device needs to be connected with other devices, number of input and output ports required must be huge. And scalability issues because a device cannot be connected with large number of devices with a dedicated point-to-point link. Next, let's proceed with the star topology. So each device in the network is connected to a central device known as hub. Unlike mesh topology, star topology doesn't allow direct communication between devices. A device must have to communicate through the hub. If one device wants to send data to other device, it has to first send the data to hub, and then the hub transmits that data to the designated device. So these are the advantages of the star topology. So less expensive because each device only need one input and output port, and needs to be connected with the hub with one link. It is easier to install. Less amount of cables required because each device needs to be connected with the hub only. Robust if one link fails, other links will work just fine. And easy fault detection because the link can be easily identified. So while the drawbacks of the star topology are, if hub goes down, everything goes down. None of the devices can work without hub. Hub requires more resources and regular maintenance because it is the central system of the star topology. Okay, we will proceed now with another computer network topology, which is the bus. So there is a main cable. Okay, this is the main cable, and all the devices are connected to this main cable through drop lines. There is a device called top that connects the drop line to the main cable. Since all the data is transmitted over the main cable, there is a limit of drop lines and the distance a main cable can have. So advantages of bus topology are easy installation. Each cable needs to be connected with backbone cable. Less cables required than mesh and star topology. The disadvantages are difficulty in fault detection, not scalable as there is a limit of how many nodes you can connect with backbone cable. Next, we have the ring topology. In ring topology, each device is connected with the two devices on either side of it. There are two dedicated point-to-point links a device has with the devices on the either side of it. This structure forms a ring thus it is known as the ring topology. If a device wants to send data to another device, then it sends the data in one direction. So each device in ring topology has a repeater. If the received data is intended for other device, then repeater forwards this data until the intended device receives it. Advantages of the ring topology. So we have easy to install. Managing is easier as to add or remove a device from the topology. Only two links are required to be changed. And the disadvantages are a link failure can fail the entire network as the signal will not travel forward due to failure. And data traffic issues since all the data is circulating in a ring. Next, we have the hybrid topology. A hybrid topology is a type of network topology that uses two or more differing network topologies. These topologies can include a mix of bus, mesh, ring, star, or tree topology. So the choice to use a hybrid topology over a standard topology depends on the needs of a business, a school, or the users. The number of computers, their location, and desired network performance are all factors in the decision. So advantages of hybrid topology, we can choose the topology based on the requirement. So for example, scalability is our concern, then we can use star topology instead of a bus technology. Scalable, as we can further connect other computer networks with the existing networks with different topologies. While its disadvantages are fault detection is difficult, installation is difficult, and design is complex. So maintenance is high, thus expensive. So we will now proceed with the different types of computer network. So a computer network is a group of computers connected with each other through a transmission medium such as cable, wire, and others. So these slides will discuss the types of computer networks in detail. So we have the local area network, also known as LAN. So local area network is a group of computers connected with each other in a small places such as school, hospital, apartments, and others. So LAN is secure because there is no outside connection with the local area network. Thus, the data which is shared is safe on the local area network and can't be accessed outside. So LAN, due to their small size, are considerably faster. Their speed can range anywhere 100 megabytes per second. And local area networks are not limited to wire connection. There is a new evolution to the LANs that allows local area network to work on a wireless connection. Next, we have the MAN or Metropolitan Area Network. So it covers larger area by connections, LANs to a larger network of computers. In metropolitan area network, various local area networks are connected with each other through telephone lines. The size of the metropolitan area network is larger than LANs and smaller than WANs or wide area networks. A metropolitan area network covers the larger area of a city or town. So in this diagram, we have the office building, a university campus, a residential area, and a government building. Next, we have the wide area network or WAN. So wide area network provides long distance transmission of data. The size of the WAN is larger than LAN and MAN. So a wide area network can cover country, continent, or even a whole world. Internet connection is an example of one. Other examples of one are mobile broadband connections such as 3G, 4G, and now we have the 5G. So we have here in the diagram a campus LAN, a wireless LAN, a MAN, uh, a dial-up connections, and other devices. Next is advantages of wide area network. So centralized infrastructure. So one of the main advantage of one is that we do not need to maintain the backup and store data on local system as everything is stored online on data center from where we can access the data through one. Another advantage is privacy. So we can set up the one in such a way that it encrypts the data that we share online. That way, the data is secure and minimizes the risk of unauthorized access. We have increased bandwidth. With a wide area network, we get to choose the bandwidth based on the need. A large organizations can have larger bandwidth that can carry large amount of data transfer and efficiency. Next, we have area. A WAN can cover a large area or even a whole world through the internet connection. Thus, we can connect with a person in another country through one, which is not possible in other types of computer networks. Next, we have the disadvantages of wide area network. So antivirus. So since our systems are connected with the large amount of systems, there is possibility that we may unknowingly download the virus that can affect our system and become threat to our privacy and may lead to data loss. Next, we have expensive. The cost of installation is very high and issue resolution. So issue resolution takes time as the one covers large area. It is really difficult to pinpoint the exact location where the issues raise and causing the problem. So now let's review all the topics that we have discussed. Okay, so data communication is an essential concept in the creation of computer networks. Prior to the invention of networks, data had to be physically carried from one device to another. With digital networks, the task is not only easier, it is accomplished much more quickly. The ability has driven the entire computer industry, including software innovations and the creation of the internet as a medium for use by both professionals and the public. As the industry grows, more people connect more devices to a network, resulting in a scope that increases exponentially. So, because of innovations in data communications technology, people can communicate and share information virtually, instantaneously, across the entire globe. And education and business concerns can take place no matter where the individual parties are located. So we have discussed the different components of data communication, which includes message, sender, receiver, transmission medium, and protocol. And there are also three different types of data flow directions. We have the simplex, which is a transmission of communication is unidirectional or one way. Then we have the half duplex. The mode of transmission, the communication is two directional. And then we have the full duplex. The mode of transmission is bidirectional or two-way, and the channel is used by both of the connected devices simultaneously. We have two types of signal, the analog and the digital signal. Then we have the different types of transmission media. Under the guided media, we have twisted pair cable, coaxial cable, and optical fiber cable. While for unguided media, we have the radio waves, the microwaves, and infrared. So we have two types of twisted pair cable, the unshielded twisted pair and the shielded twisted pair. For the different network devices, we have repeater, hub, bridge, switch, routers. For the various computer network topology, we have the mesh topology, the star topology, the bus topology, the ring topology, and the hybrid topology. Okay, for the types of computer network, we have the local area network or LAN, which is used for small places. We have the metropolitan area network or MAN, which covers the larger area of a city or town. Then we have the wide area network or WAN, which provides long distance transmission of data.